Hello. So for the past year or so, I've been working on some iOS stuff and various other things that involves APIs. So I thought I'd share a couple of the things I learned about API design and the kind of the principles that I apply when making API. So first of all, why would you want to make a good API? Well, whenever someone's using your code, they want it to be really easy. They don't want to get frustrated and stuck up on little things. And you also don't want to make it difficult for them to mess up or like create something completely wrong. And chances are you've probably encountered this problem and you're probably like, well, why did they just do it this way? So it's just kind of a good idea when you're making your own code that you also follow principles. So I put together 5 principles of good API design. The first one is make it familiar. Make sure that you know the platform and like the frameworks that you're working with, and you know the kind of styles of what works well. And that, make sure that you use those because people that are using your code are going to be expecting that kind of behavior, so you should follow that. The second one is make it specific. So don't try to pack in a bunch of features to your API that chances are no one's going to ever use. So you should really make it like designed for one specific thing and do it really well. Make it understandable. If someone's reading your code, it should be going all around and doing a whole bunch of different things. It should be kind of very readable and clear, be able to read right through it. And that kind of goes with documentation too. So you can document your stuff, but it should be easy enough to just look at and read without having to go to documentation. You should only have to go to that in some worst case scenario. So make it easy. You want people to get started really easily. You don't want to have a lot of configuration. Just kind of have sensible defaults and don't have a lot of unnecessary things. And make it difficult. You want to make it difficult for people to break it. You don't want people to accidentally think that they're doing the right thing and completely mess it up. So you want to make it difficult to do something that users aren't expecting. So let's talk about some examples. In UIKit, which is the user interface framework for iOS, there's 2 classes, UI Action Sheet and UI Alert View. And UI Action Sheet looks like this. It kind of appears from the bottom of your display. Has a title, a couple of buttons, maybe a cancel button. Basically, you just want to give it a title and the names of the buttons. And then you want those buttons to correspond to some kind of action, right? It seems pretty simple. You'd be surprised how messy it gets. And UI Alert View is very similar in style, which is a little bit different in Dreams. So let's look at the current API. You might be thinking, all right, how difficult could it be? Seems pretty straightforward. So here it is. And this is the initializer, which is kind of a constructor, as you might be familiar with in other languages. And that's one method. With line wrapping, that's 4 or 5 lines. It has like 5 arguments and a nil-terminated list. It's kind of a disaster, especially because a lot of these parameters can be null. So why would you have an initializer where a lot of them are just turned off? It should just be reasonable with some kind of reasonable defaults. Oh, another problem with having a nil-terminated list is that you can't pass in a data structure. So if you wanted to do this dynamically, you can't because it's done at compile time. Then we have some properties, a delegate, a title, style, that's fine. And then it gets messy again. So we have some kind of index of different buttons. I don't know why anyone would ever want to know the index of a certain button if they just created it. Like if they created it, they should know. They shouldn't be like creating it and then asking to make sure it's right. It should just work as expected. And I don't even know what an other button is. And then some things to show the action sheet, which is pretty okay. And then this is if you want to fake a click on one of those button indices. So first of all, you have to know which index to click on. So in order to do that, if you wanted to explain to someone, okay, tap on this, right? You wouldn't say tap on the 3rd button. You tell them like the name of the button, right? So this doesn't make any sense. Why would anyone think this is reasonable? So here's an example of like using that API to create something. So say you're tapping on a link and you want to have some options for opening that link. So you have, you're creating it, giving a title, cancel button title, some other things like open and copy. Seems pretty reasonable. You're showing it. And then what happens if someone taps on it? Well, you get a callback with the index that was tapped. So now you have to go and map the index to the name and then figure out which action it corresponds to. And it quickly becomes a nightmare. Now this is only for one action sheet. If you have more than one in a certain view, you're going to have to figure out which action sheet it is, and then which buttons it has, and then which index it corresponds to. This is way more than you should ever have to keep track of, and it quickly kind of becomes disaster, especially if you want to selectively add or remove certain buttons. You have to correspond that with the indices.
What language is this?
This is an Objective-C, but I've tried to highlight it to kind of show like the basic method calls. So anything wrapped in brackets is kind of similar to something with parentheses at the end. It's basically a function. It's more complicated than that, but at face value it looks like that. So I kind of rewrote it. I rewrote the interface, same functionality. It's just a lot easier to use and a lot difficult to mess up. So it's pretty similar. You kind of start it with a title and some options, but right now you already tell it the action when you create it. So you don't have to ask it for the action later. You just create it and show it, and it just works after that. So here's what the old code looks like, or the current code in the framework looks like. It's got a whole bunch of different stuff and it's spread across different parts of your code. So now, like, if you want to change something, you have to go to another part of your file, make the corrections, and then test it again. Whereas the rewritten one, it's all in one place. It's very logical. So let's see if it passed the test. So it's very familiar. People who are familiar with Objective-C and these frameworks, this is pretty standard stuff. The second one is specific. It's not adding a whole bunch of features. It's actually simplifying it quite a lot. It's much more understandable. Everything is in the same spot, so you know like what corresponds to which action. You don't have a bunch of numbers representing different indices of which buttons. And it's harder to mess up, especially when things get more complicated and you have multiple action sheets and a certain view controller. So that's just one example. I have another example of the network activity indicator on iOS. If you're familiar with it, it's a little spinner on your status bar. An app can tell that spinner to turn on and off depending on any network activity that may or may not be happening. So you're like, all right, well, how difficult can it be? It should just be on or off, one property. Well, it turns out it is just one property. So what's wrong with it? Well, networking code often runs in parallel. There's multiple threads. So things are turning this on and off. So what if you have two things running? You turn something on, and then when it terminates, you turn it off. But something else turned on in the meantime. So something can turn it off even though it should be on the whole time. So something as simple as one line of code could actually be kind of a disaster. So actually what happens is people think that they're using this correctly and never really test it fully. And then it ends up breaking a lot of apps, and then people don't use it because it's a nightmare. So a very simple solution is to add two methods. One to indicate when you start a certain activity and one when you end it. And that way a counter can be incremented or decremented. When that counter is 0, no network activity is being done, and you can just turn off the spinner. So no particular network activity needs to turn it on or off directly. So here's what would happen if you naively used the original API. You have a bunch of simulated activity starting and stopping. And as soon as I stop the first one, all the network activity just turns off. And that's clearly not appropriate. So by simply just changing, setting it on and off, began and ended, you can get the desired behavior, which is as soon as you cancel all of them, that's when the network activity turns off. So it's really, really simple, but just like, you need to keep in mind what's going to be happening and make sure all your behaviors are as expected. So that's it. Thank you to Dr. Goldschmidt, Morphy, Sean Sullivan, RCOS, and I'll take any questions.
So what was that void before some other calls?
Okay, was it the big block of code?
Like that?
It was somewhere in here.
That previous file that you had.
Oh, those are in here.
Yeah.
So basically, it's a function that returns void, so nothing happens. Because when you call those, you shouldn't really need to know anything about it. You're just marking something that's starting or stopping.
Right. So the type needs to be specified when you're calling your function.
Oh, this isn't. Sorry, this is just the interface for it.
Okay. That's not used. Okay.
Yeah. So this is just the interface. When you were to call it, you do self, and then begin network activity with self.
Have you handled if like an app crashes and it never gets the call ended network activity, and so now you've got an increment that's never going to be decremented?
So that's actually handled by the operating system. So whenever the app is present, it has control over the spinner, but when it's not, the operating system has control over it. So when it crashes, everything's just off. Yeah, yeah, that's beyond this API actually.
You're talking about like making your APIs too general, your problem.
Yeah.
It's like, what if you have a lot of parameters that you want to specify? So do you like artificially limit people and have a simpler API, or do you give them more general functions?
You have the probably have the settings object that allows changing specific settings from the defaults on that.
Yeah, I mean, you can have
Count
default
settings
values,
object
but
of the structure.
that still gives you like a slightly ugly API.
Yeah, so I guess, let me go back to one of the, something I had just kind of, if I had this first one, there's just one that should everything, and a lot of them are just inbuilt. Whereas this one, I can just selectively turn on to one side of the view, and it's a little bit more complex. Yeah. Especially for something like this. If something meets those requirements, it should be initialized. But a lot of these aren't necessarily required. Does that make sense, or am I not answering the question?
Yeah.
Okay.
Shouldn't the network spinner be handled by the OS moving?
Ideally it would, but some network activity shouldn't really be shown. So like if you're syncing something to the cloud, it would just be on all the time. So it's only really for select things. It's more of like a user interface thing. So the user thinks only certain network activity is happening, but really it's not.
Couldn't you replace your API with one call to say this application requires the use of the network spinner, et cetera, et cetera?
But you could be having that like both types of network calls in your say that. So you could have stuff that really shouldn't be affecting it, and then stuff that should. So sometimes you might be calling stuff and it's like turning it on and off really quick. They're really short. In that case, it's probably not even worth showing because the user just like sees something flashing in the corner. It should really only be for something that's like taking something that they're waiting for it to complete.
I was just gonna say it's like it's really only used for heavy data usage.
Yeah, and it's also located. Let me show you where it's located. It's located next to the carrier information. So like if you're waiting for something to load, you might be like, why is this taking so long? You're looking at there, and you're also seeing your carrier information. So that's just more of the design of it.
That's it.
This is more of a question about your presentation, but what did you use for syntax highlighting? Because it wasn't Objective-C highlighting, so.
Right. So I just put it in Keynote and I highlighted just certain things.
Oh, you just like manually went, okay.
Yeah. The reason I did that was because not everyone is familiar with Objective-C, and I thought maybe just highlighting certain names would kind of make some kind of sense.
Cool.
All right. Thank you, guys.